What's up guys, it's me again, and today we're going to take a look at linked list data structure and ADT of linked list. Also guys, before we start, be sure to hit that subscribe button and smash that like button. Let's get to 100 subscribers before the end of this year. I know there's like not a lot of time left for the year to end. So let's get started. First of all, what is linked list? So a linked list is a linear data structure in which elements are not stored at contiguous memory locations. And it's true, right? Because linked list में क्या होता है? There is a node, say there is a node A, and then A might be located at some memory location 10, which is linked to B, which might be located at some memory location 50. So it's definitely not contiguous. It's basically node linked with this pointers all around. And some basic description about linked list, that it's a dynamic data structure, right? And let's just go over some advantages of linked list as a dynamic data structure, because this is a question which I've seen in the previous year papers. So basically, it's a dynamic data structure in the sense that if you want to make if you want to expand the capacity of a linked list, you can do that. Whereas in static, if you have initialized it as 5 ka array, then the length of the array will always stay 5 or whatever you've defined it to be. That is not the case in dynamic data structures. You see, size of memory can be changed by allocating or deallocating as needed. Insertion and deletion is quite easy because you just have to delete the node and kind of change the links back in. So say for example, I have another C comma let's say 59, right? And now say I want to delete B. So I'll just delete B, and जो भी ये pointer है, I'll just make it point over here. Done. The linked list is like still operational now. It's that easy. Instead of arrays में you have to shift every element एक position आगे या पहले according to your requirements. So that's not what we want. Okay guys, so before we start with the ADT, let's just discuss a few properties about the linked list. So these are actually some of the components of the linked list, where the header node is actually the first node. Now in our case, I don't think for the singly circular and doubly circular linked list, which we'll discuss today, we won't really have any special properties over here. But this is true in case of generalized linked list or other types of linked list, right? So it's basically a special node which may contain some special data. This is not that important. So the data node is basically the second one, which is the actual kind of where the data and the address of the next location is stored. So A comma 10 over here is the data node. Then head, we'll talk about the head pointer, which is a pointer to the first node of the list, and is basically the only way to access the list. So let's just say over here I have a container, I mean a variable obviously, its name is head, and this is having the location of the first node, right? So every time I want to access the linked list, I'll first go over here and then I'll be able to go to A. If this is non-existent, then there is no way to access the linked list as such. I mean, you can't access it at all. Then there's the tail pointer. So just like we have the head pointer over here, we can also have a tail pointer pointing to the last element. So yeah, this is tail and this is head pointer. Now we'll start with the ADT of the linked list. So first of all, we have to define the structure. We have to define the node, right? So we have to step one will be define the node or data node. So to define the data node, we'll use a structure since you can use a class as well over here. Depends on if you want to make the objects public or private. So for structure, the objects are by default private. Public. For structure, the objects are by default public, which is why it's more preferable because you can use it anywhere. And anyways, it's not actually holding any data, it's just a template. Yep, over here we'll define the head pointer first as a private instance variable. It will contain the address of the starting location of the linked list or the first node. Then we'll define, so now we have to define the constructor. After the instance variables, you have to mention public. Even if you're writing this down, I think you should keep this in mind because else it doesn't really make sense to write it as a form of class. So we have insert append. The other operation will be displaying the linked list so that we can view the linked list. And the last one will be deleting the linked list or deleting a single node, not the entire linked list. The entire linked list will be deleted by the destructor, which we'll have to define on our by ourselves. Right, now that we've defined all of this, we'll take a look at the functions one by one. So now we've defined the constructor. We'll define the insert function. So what the insert function will basically do, आपके पास say you have a node over here, a comma 5. This is your head node, and now you want to insert another node, c, comma. You have to insert. You want to insert a new node c. Say you want to insert this at the end linked list के. So you just take it. So first of all, what we'll do is we'll traverse the linked list and say कि okay, इसको हमें end की तरफ चाहिए. Like we want to have it at the end of the linked list, right? So last node will be B over here. The last node is B क्योंकि B का next pointer null है. पहले मैंने वो गलती से लिख दिया 10, but it's actually null. So we've encountered null over here, and what we'll do is we'll put C over here, and C का जो भी address होगा, let's say in this case C का address is 10, and this B connects is pointing to C का address, and this is null. Right, now we have inserted it. So this is basically how it is going to work. But for that we'll need C हमारे पास data था, so we'll need to accept data as well as the index or the position at which. So this is the insert node function. Yeah, so this is what it does. It's basically going to start from the beginning of the linked list, and जो भी index है, according to that index it will check. So see over here, every time you write and insert a node algorithm or pseudocode, whatever the question asks, you have to use this condition. So if the head does not exist, either you return an error or you append that node to the head by creating a new head. Right? In this case, I've decided कि this is insertion and not appending. So I'll just tell the user कि you messed up. Start over again. Basically is what I'll ask them to do. Our next function will be obviously appending the node, like we just said. What a great segue, right? Haha. Is basically like I described over here. Appending is basically insertion at last. But the thing is that logic thoda sa alag hai, which is why we're doing it this way kind of is a bit more efficient. Just saying ki okay, index wise karte jao. Kyunki over here, see, I'm creating a new head in case the head is not existent. So that is going to come in handy. Now we'll move on to the next function, which is going to be display list. What display list is going to do is quite simple. It's just going to display the entire list, right? इसमें ऐसा कुछ है नहीं. This is the function. Over here, what we'll do is if the head is not existing, that means linked list exist नहीं करता. So दिखाओगे क्या ना? So that's exactly what it says. And over here the nptr.next ही while में है because if nptr का next exist नहीं कर रहा है, so it automatically becomes a boolean value of false. So if you want to save some time writing your algorithm, then you can write it this way. Okay. Yeah, other than that, I don't think there's anything important in display list. It's pretty easy. Display list is definitely like the easiest of them all. Okay, let's move on to the delete function. What the delete function does is it takes your data and it will find. अगर data है इसमें, तो वो उसको find करेगा and उसको delete करेगा. It will delete that particular node. So let's take an example over here. Let's say we have these nodes A, B, and C. ओके ए एंड वी हैव अ हेड। तो ए में कुछ भी डेटा हो सकता है, कुछ भी नेक्स्ट पॉइंटर का वैल्यू हो सकता है। व्हाट वी आर गोइंग टू डू इज हेड से जाएंगे, वील चेक कि डज ए हैव द रिक्वायर्ड डेटा, नो, does b have the required data, maybe yes, let's just say in this case it has a required data, so we have to delete node b, right? This is what we have to delete. So what we are going to do is in this loop we're checking ki is the data of head equal to iska data, the one which we want to find. The reason being अगर starting में ही है तो सब constant time complexity पे हो जाएगा, right? ये एडिशनल क्या, तो फिर इधर का कंप्यूटिंग पावर बचेगा. दिस इज अगेन टू रिड्यूस द टाइम कॉम्प्लेक्सिटी. नाउ इन दिस केस ये ऐसा नहीं है बिकॉज एक का कुछ हुआ नहीं, डेटा मैच नहीं हुआ. देन वी गो इनटू एल्स लूप. एल्स लूप में वी असाइन एनपीटीआर इज द हेड एंड जब तक एनपीटीआर का डेटा इज नॉट इक्वल टू डेटा दिस विल कीप रनिंग एट द मोमेंट. सो व्हाट इज, इसका मतलब क्या है कि ए को चेक करेगा, ए का डेटा नहीं है, ठीक है चलते रहो. नाउ दिस इज इक्वल, सो नॉट इक्वल टू का कंडीशन फॉल्स हो जाता है, so this will stop at b and we'll come out of the while loop. This is basically incrementing. Now what we're going to do is there's a bptr which I've defined over here, which is basically कि b इस नोड का एक इस नोड के नेक्स्ट का पॉइंटर लेंगे एंड nptr के नेक्स्ट का पॉइंटर इस नोड के नेक्स्ट को असाइन करेंगे एंड nptr को डिलीट करेंगे. What this is basically doing is now currently as you can see bptr will point to a and nptr is pointing to b. मतलब nptr is b, it's pointing to b, so we are deleting nptr and assigning it to null. But then जो bptr है, जो ये है, इसको हमें c को असाइन कराना पड़ेगा. So that's what we are doing कि bptr का next will point to c जो कि nptr का next था, and this is how we deleted it. Yeah, so this is done. Now there's just the destructor. I don't think it's necessary for you to write this, but just in case, singly linked list, that's the name of our class. Okay, fine, I'll explain you what's going on over here. What this is basically doing is we have an nptr and a bptr pointer, so we're using two pointers, and what we're doing is we're cycling कि जैसे अभी यहाँ पे हमारा था, let's just bring this down. So जैसे यहाँ पे we had this, तो हम हेड से ए को जा रहे हैं, ठीक है. नाउ nptr is pointing at a, bptr hasn't pointed to anything yet, ठीक है. So now bptr is nptr का next, so now bptr is pointing to c and nptr is a पे, and now we deleted nptr, so a delete हो गया, now c है, तो फिर we assigned nptr to c, तो फिर नेक्स्ट आइटरेशन में c भी डिलीट हो जाएगा. सो ऐसे एक एक करते करते वी कैन डिलीट द एंटायर लिंक लिस्ट फ्रॉम द स्टार्ट to the end by kind of cycling it between nptr and bptr. Yeah, and that's the entire ADT of a singly linked list. That's it. This was, I hope, a short one. And yeah, all the best.